All right, we have been talking about inequalities, and we've been talking about inequalities, and we've done some compound inequalities, adding and subtracting, multiplying, dividing, all that great stuff. We are going to move on to solving absolute value inequalities, and so we've got a couple definitions here first. So an absolute value inequality is just as it sounds. It's an inequality. Whoops, come on. Work with me here. It's an inequality with an absolute value expression. Okay, it's just as simple as that. It's just an inequality with an absolute value expression. If I'm looking at absolute deviation, this is what we've kind of talked about a little bit before. So I am looking at how spread out is my data. Oops. The other question that I'm looking at with absolute deviation is how I'm looking at how far away are the values from the mean. Okay, that's kind of the question I'm asking, is how far away are my values from my average? So if I'm going to do absolute deviation, it's going to look like this. I'm going to have the absolute value of x minus my average is going to equal my deviation. Absolute value of x minus my average equals my deviation. So we're going to look at what does the inequality x, the absolute value of x minus 3 is greater than 5 look like on a number line. So when I'm doing this, I'm going to kind of just imagine that this says x plus, or not plus, x minus 3, I'm going to say is equal 5. Absolute value of x minus 3 equals 5. We know how to solve these, right? When I solve these, I need to break it into two equations. So I have x minus 3 equals 5, or x minus 3 equals negative 5, right? And then I can just solve like I normally would. So I would add 3 to each side, gives me x equals 8, and x equals negative 2. Okay, so those are my solutions. I know that when I solve it, that's what I get. But I'm dealing with an inequality here. So I need to look at, well, I'm using a greater than sign. Since I'm using a greater than sign, that means that I'm going to use an open dot. So I'm going to put an open dot over here on negative 8. I'm going to put an open dot, or positive 8, and then I'm going to put an open dot on 2. So the other part of this is that I need to figure out what directions my arrows go. Right, so am I going to connect this inequality, or am I going to draw my arrows in opposite directions? And the way that I'm going to do that is by testing some values. So I'm going to test some values to the left of my point here. I'm going to test some values in the middle, and I'm going to test some values over here, so that I can look at where is my inequality true. So to the left of my negative 2, let's test negative 5. So if I test negative 5, I'll have the absolute value of negative 5 minus 3. I want to know, is that greater than 5? Well, I've got, if I do this, negative 5 minus 3 is negative 8. So I have the absolute value, oops, I gotta get my black. I have the absolute value of negative 8 and is greater than 5. And yes, that is true, right? The absolute value of negative 8 is greater than 5, so this is a yes. This is true. It's true over here. The next point I'm going to test is, let's test 0. 0 is a good number to test if you can, because zeros are really easy to work with, right? So if I'm going to test 0, all right, I got to try to recalibrate this here. I don't know why it's being weird. All right, we'll see if that helped. Okay, so I'm going to test, oh, it did. Test 0. So then I'll have the absolute value of 0 minus 3. I want to know, is that greater than 5? Well, I have the absolute value of negative 3. Nope. That is not greater than 5. So my middle section is a big fat no right there. So then I need to test one on the right-hand side. So I'm going to test 10. I'm just picking numbers that are easy to work with, right? So if I test 10, I'll have the absolute value of 10 minus 3. I want to know, is that greater than 5? 10 minus 3 is 7. The absolute value of 7 is greater than the absolute value of 5. Yes. So this is also true, whoops, over here. Okay, that's a lot of work to just figure out a simple thing, is what direction am I shading in? Well, it's not true in the middle. I have a big fat no here. And it is true on the outsides. So that means that I am going to put my arrows out this direction, right? I'll just use this. My arrows are going to go out to the sides. There we go. That's a whole lot of mess, but hopefully yours looks better than mine. So that's a long, tedious process, right, to get to my final answer of what my solutions are. So I have some tricks, some rules that we can talk about. So my first one is if the absolute value of an expression is less than or equal to a positive number, and then I'm going to have you cross out 0 here and write less than or equal to 0, or less than or equal to 0, and I'll explain why a little bit later. My format is going to be like this. I'm going to have my expression, whatever that is, whatever is inside my absolute value bars, is less than or equal to the positive number. And then I'm going to highlight this, here we go, and my expression is going to be greater than or equal to my negative number. That and is important, right? Because it's going to clue me onto what my graph is going to look like, what my solutions will look like. So an and statement means that I have 2 points and they're connected. So instead of my arrows going in opposite directions, they're going to overlap. That's what that tells me. So an example of this, I could do the absolute value of x plus 7 is, let's say, less than or equal to 2. The way that I'm going to write these out then is I will have x plus 7, get rid of this a little bit, oops, that was too far. X plus 7 is going to be less than or equal to 2, and x plus 7 is going to be greater than or equal to negative 2. And then I would solve from there. I'm not going to solve here because this is just an example of how I would set up these equations, right, these expressions. So then my next one, if the absolute value of an expression is greater than or equal to a positive number or 0, it's going to be kind of reversed. So I'm going to have my expression is greater than my positive. This time, it's not an and statement, it'll be an or statement. Or my expression will be less than or equal to my negative number. So this is how this is going to look. Let's say I have the absolute value of c minus 1 is greater than 5. So if I break this up, I'll have c minus 1 is greater than 5, or c minus 1 is less than negative 5. They'll go in two opposite directions. That kind of looks like a K, but it's c minus 1 is less than negative 5. And then I would just solve for c. Or means that my arrows are going to be pointing in opposite directions, right? Okay, this next one then, if the absolute value of an expression is less than or equal to a negative, I'm also going to add here or less than 0. This is where my 0 stuff comes into play. So just think about this, right? What we know about absolute value from before is that the absolute value of something can never be negative, right? It can never be negative because absolute value by definition is how far away something is from 0, and our distance is positive. So if I'm looking at the absolute value of an expression as being less than a negative number, is that possible? The answer is no, it's not possible. The same thing happens with 0, right? If something is less than 0, that means, number one, I'm not including 0 in that solution set. And so if something is less than 0, it's going to be a negative number. And so the absolute value of something can never be a negative number. So if I have something that says the absolute value of an expression is less than or equal to a negative number, I just have no solution. That's it. These are awesome because you don't even have to do math. You can just look at it and use common sense and say, oh, well, I know absolute value can never be negative, so it's no solution. So an example of that could be like the absolute value of 8x minus 11 is less than 0, right? In this case, I have that the absolute value of something is going to be less than 0, which means it has to be a negative number, which means it can't be true. That's not going to be a true statement. So, similarly, my last one, if I have the absolute value of an expression that is greater than or equal to a negative number, this one is going to be many solutions. In big ideas, it often calls this all real numbers. It's the same thing. And this one also makes sense. So if you think about it, right, the absolute value of something is always positive, and we've already established that. I've drilled that into you, right? The absolute value of something is always going to be positive. And so if you think about this, if I'm comparing the absolute value of something to a negative number, my positive number is always going to be greater than my negative number, right? So for example, if I have the absolute value, let's do like 9 minus x is greater than negative 3, something like that. My absolute value, regardless of any number that I put in there, is always going to be greater than negative 3, right? Because it's always going to either be 0 or a positive number, depending on what I put in there, right? Because so like if I put in 9 minus 9 is 0, the absolute value of 0 is just 0. 0 is greater than negative 3. I could put in 10. 9 minus 10 is negative 1. The absolute value of negative 1 is a positive 1. 1 is greater than negative 3. Anything that I put in there is going to be greater than a negative number all the time. So that one is many solutions. Okay, so we've got some examples. The absolute value of x plus 3 is less than or equal to 2. If I look back at my chart, I'm going to flip back over here. I know that this is going to be less than or equal to, means that I'm going to have an and statement here. So I'm going to go back over here, and I'm going to make a note to myself that this is an and statement, so that I know what's happening over here. And. So what this is going to look like, I'm going to break it up into 2, right? So I'll have x plus 3 is less than or equal to 2, and x plus 3 is greater than or equal to negative 2. Now, something else that I will say about this, if it's kind of hard for you to remember the different chart things, think about when we're talking about multiplying and dividing by negative numbers. So we can think about this like when we're multiplying or dividing by negative numbers. So I'm starting off over here with this, right? And that's just normal, right? It's x plus 3 is less than 2. That's normal. But absolute value says that I also have to do the negative version of that. And so over here, I have the negative version of that, right? But I kind of have to think about it like I'm multiplying or dividing by a negative number. So it makes sense that my sign's going to flip because I have a negative number, right? So now all I'm going to do is solve these. So I'm going to subtract 3 from both sides, right? Then I get that x is less than or equal to 2 minus 3 is negative 1. Subtract 3 over here also. I get that x is greater than or equal to negative 5. Okay, this is an and statement, right? So it makes sense it's going to be one long inequality, and I can write that out, right? My minimum here is negative 5. Negative 5 in relation to x is less than or equal to x. These two things say the same thing. They're just reversed, right? And then over here I have that x is less than or equal to negative 1. That's how I'm used to seeing compound inequalities that use and, right? It's the same thing. So now I just need to graph this. I'm going to do a closed dot on negative 5. Negative 5. Closed dot over here on negative 1. And then these guys are connected. Okay, letter B. I've got the absolute value of 3c minus 5 is less than negative 2. Now, I've had lots of people that just go straight into solving this equation. But stop and think for a second, right? I have the absolute value of something is less than negative 2. Can the absolute value of something be less than a negative number? The answer should be no. It can't be. So this is just no solution. I don't even have to do any math. It's just no solution. I just have to use my brain and think about it. So that's it. And we can move on. So my next one, I've got x plus 1 is greater than or equal to 3. If I look back, I've got greater than or equal to. I need to come down and look at my chart. Greater than or equal to is this guy here, right? So I'm looking at an or statement. So this one is going to be or. I'm just going to make a comment, or that does not look anything like the word or. I'm making a note over here. So now I can just split it, right? So I'll have x plus 1 is greater than or equal to 3, or x plus 1 is less than or equal to negative 3. Solve by subtracting 1 from each side. X is greater than or equal to 2. I'll do the same thing over here. X is less than or equal to negative 4. Because it's less than or equal to and greater than or equal to, I will have closed dots. So I'll have a closed dot here on negative 4. I'll have an open dot over here on positive 2. I have that x is greater than 2, so that's going to go this direction. Whoops. It's going to go this way. X is less than or equal to negative 4. That's going to go that way. Which makes sense because I know that this is an or statement, right? So that's my solution. Letter B. The absolute value of 12 plus w is greater than negative 5. This is another one. Think about it. The absolute value of something is greater than a negative number. If I know that the absolute value of something is greater than a negative number, I know this is many solutions, or all real numbers. So that's what I'm going to put. all real numbers. In Big Ideas, it'll have you graph this, and if you were to graph all real numbers, it literally just wants you to notice, like, oh, I'm on the whole line. My answers are just the entire number line. Letter C has some extra steps. So I only break my inequality or my absolute value apart when I get my absolute value stuff by itself on its own. So the first thing that I need to do in this case is I need to get my absolute value by itself. So the first thing that I need to do that is I'm going to add 5 to both sides. So I've got 2, oh no, not 2. I've got 3 times the absolute value of 2t minus 3 is greater than 16 plus 5 is 21. Now I need to get rid of my 3. When it's right next to this, like this, I know that I'm multiplying. So to undo that, I'm going to divide by 3, both sides. These cancel. And so then I'm left with the absolute value of 2t minus 3 is greater than 7. Okay, something to remember, I've noticed this in a couple people's work. I can't drop the absolute value bars until I get to this point. Until I'm ready to break my equation into 2 parts, I'm not going to drop my absolute value bars. So now that I've got my absolute value by itself, now I can write my 2 equations. So I'm going to have 2t minus 3 is greater than 7. Now I got to think, is this going to be an or statement or an and statement? So I'll look back. It's greater than, it's going to be an or statement. Or 2t minus 3 is less than negative 7. Now I'm just going to solve. So I'll add 3 to both sides. Then I'm going to skip down here. I'm running out of space. 2t is greater than 10. Divide both sides by 2. I get that t is greater than 5. Do the same thing over here. Add 3. I get 2t is less than negative 7 plus 3 is negative 4. Divide both sides by 2. T is less than negative 2. Something that I like about absolute value problems, and this is a good case of it, right, is I do the exact same steps regardless of what I'm doing. So I have these 2 equations. If you notice, over here I add 3 first. Over here I also add 3 first. Over here I then divide by 2. Over here I also divide by 2. Right? I'm doing the same thing to both equations, so it's pretty straightforward. It's pretty simple in that way. I am solving 2 equations, but I'm doing it the same way, even if I get different answers. Okay, so this is an or statement. That tells me that my arrows are going to go in opposite directions. So I'm going to have an open dot at negative 2. We'll say it's right there. I'm going to have an open dot at 5. We're going to put it here. And my arrows are going to be pointing in either direction. Can't really see my arrows very well in here. Highlight it. Arrow, arrow. All right, last one here. Absolute value of 4t minus 9 is less than negative 5. This is another one where I'm going to stop and think. I have the absolute value of something is less than a negative number. If it's less than a negative number, that means this is a no solution. I can't solve it. We like those. Those are easy. All right. We're going to just do this on your own part, and then we will stop for this first half of section 2.6. So what I might do is when I'm looking at this, I might make note of things that I see. So this is a greater than. Greater than, I remember, is or. This is a less than. Less than, I remember, is an and. This is a greater than, so this could be an or. This is the less than or equal to, this could be an and, right? These are all potential, but I do have the option of having it be no solution or many solutions, right? So let's look at this. Absolute value of x minus 4 is greater than 12. So then I can just split right away. So I'll have x minus 4 is greater than 12, or x minus 4 is less than negative 12. Just going to add 4 to both sides. Ooh, that does not look like plus 4. I'm going to add 4 to both sides. Still doesn't. Let's try this one more time. Oh, bingo. So then I have x is greater than 12 plus 4 is 16. Do the same thing over here. Add 4 to both sides. I get that x is less than negative 8. When you're doing these now, I really want you to get in the practice of like boxing your answers, right? So that I know, oh yeah, I'm done, and here's my solution. Okay, my next one is an and statement. The absolute value of 4x minus 6 is less than 12. So I'm going to have 4x minus 6 is less than 12, and 4x minus 6 is greater than negative 12. Start by adding 6. I get 4x is less than 18. Divide each side by 4. I'll get x is less than 9/2. Simplify it. Do the same thing over here. Add 6. I get 4x is greater than negative 6. Ooh, goodness sakes. Perfect. I'll divide both sides by 4. I get that x is greater than, I can simplify this, negative 3/2. So I've got negative 3/2 and 9/2. And if I were to write this as my compound inequality, my minimum is negative 3/2 is less than x is less than 9/2, right? If I were to write my solution, normally that's what that would look like. Okay, my next one, the absolute value of x minus 4 is greater than or equal to negative 12. Based on the sign, this would be an or statement, but I can also notice that this is one of my special cases, right? I have that the absolute value of something is greater than negative 12. So I know right away, this is all numbers. Many solutions. Okay, my last one, the absolute value of 4x minus 6 is less than or equal to negative 12. It looks like it would be an and statement, right? But in this case, I'm looking at this and I'm seeing, well, I have that the absolute value of something is less than a negative number. I know that that can never be true, so this is no solution. All right, this is where we're going to stop today. We'll move on and finish the rest of 2.6 on Monday.